Hey, learn the first three. 1, 2, 3. You just need to learn those. I mean, until you get there, you still multiply by pi over 180. Luke, what do we get from 30, 45, and 60?
Pi over 6, pi over 4, and pi over 3.
Good. Pi over 6, pi over 4, pi over 3. Okay, 30 and 6, you're kind of flipped with the 3s and the 6s for that. All right, now kind of going through here, think multiples. So what times 30 gives you 210? 7. So just make it 7 pi over 6. Okay, so you get 7 pi over 6. I'm just going to go down here. What times 30 gives you 390? 13. 13 pi over 6. Now, the 45s I know are harder. It takes a little bit longer to get familiar with those, but you can just do multiples of them. I mean, just keep adding 45 till you get to the 1. Or multiply. Just take, actually go through it. So this should be 3 pi over 4. And this should be 5 pi over 4. And then 60 will go into 180. It'll be 3 times pi over 3, but make sure you reduce that. And I get 3 pi over 3, which is pi. And then 420. And you can even lop off the zeros and just think of 6 and 42. 6 times 7. And so it's going to be 7 pi over 3. Okay. So just get in your habit, force yourself to do those little things to help things sink in. All right, we will go over some guided notes here in a second. Let me hand those out. Take a look at those answers, and let's see how far those quizzes back up. Well, I want to go over one thing on the quizzes first. Hold on. Number 15. Number 15. And Ryan, what's your sequence for 15?
I got it wrong.
What's your sequence?
Like it says 4, -8, 16, -32, 64. And then n is equal to 12.
All right, so they're just going to be different numbers. Here's what you got to watch on 15. Your R value for the 1 is -3. And so it is a geometric sequence, and they want the sum. So the sum is a sub 1 minus, or is it 1? I can't remember. Oh, a sub 1 times 1 minus r to the n power over 1 minus r. So when you set this up, a sub 1 is 5. You got to think of this as 1 minus r is -3 to the 10th power all over 1 minus -3, which becomes +3. Some of you just made that a plus. Can't do that. Okay, you can't do that. You got to take -3 to the 10th power. -3 to the 10th power, is that going to be a positive or negative value? It's going to be a positive value. So now it becomes 1 minus that positive value. So here's what you got to watch. So like on your calculator, I mean, if -3 to the 10th power is that, 1 minus that will give you that, and you get multiplied by 5. If you type it in your calculator correctly, you'll be all right. You'd have to do 1 minus, parentheses, -3 to the 10th power. That's still going to give you the same thing. What you can't do is make it 1 plus 3 to the 10th power. That's a different value. Okay, totally different value. So just be careful on that. That was probably the biggest, most common mistake. And over here, it's going to be r is -2. So the sum is going to be a sub 1, which is 4. Bless you. 1 minus -2 to the 12th power, all over 1 minus -2, which is 1 plus 2. So right there, you got to be careful. So you're doing the minus and negative, and you made it a plus. Got to watch that power. Okay. All right, I'm going to collect that. Take a look at 96 and 108, and the others if you need to. Like I said, I'll get these in the grade book. If when you turn it in your homework, it says late, don't worry about that, because we just have to finagle the due date with the end of the 9 weeks and with Canvas. It's a long story. Ken, yes, you might know it from Mr. Gulato, but don't worry about it.
It's fine. Oh, no.
Thank you. Let me get my book.
Yes.
You should never write.
That's exactly right. Hey, you got nothing. So, all right, any questions off on these problems? 525. So 93, 96. Arc of a pendulum. 97. Hey, for 97, just making sure you're on the right case there. 97, you got a pulley with a 4-inch radius, and then they have to lift, I think, the shark 6 inches off the ground. So when you're pulling with the rope, okay, the rope is going to travel the arc length. So you got to think of that. The 6 inches has been moved up as an arc length, and so theta is equal to 6/4, but that is in what? Radians. That is in radians. They want the nearest degree. So in this case here, you got to take 6/4 times 180/pi. All right, for that to get that 86 degrees. Okay. All right. Any other questions though, or any questions? So they take a look at. All right, I do got some guided notes. Linear speed and angular speed. You'll hit this in physics. You haven't hit it yet. I just checked. But you will as well. Yeah, I saw that. Maybe it's something from the box.
Why? I don't think she has to do that when they just use money. Me? Great. I'm good. I am. Singular.
There you go.
Actually, April's okay.
Oh, okay. Oh, I'm assuming it's about 7 inches.
Volleyball is just something that. Yeah, it's just not something. Yeah.
Alright, got a little visual aid here. So hopefully it'll help you out. Got a wheel, borrowed it from Mrs. Franchesnick. She was so kind with music. Alright, so we're gonna deal with it. Anytime a wheel makes a revolution, you got two things going on. You got linear speed, you got angular speed. The angular speed is just the angle it goes through. Linear speed is a distance. If a wheel with a 10-inch radius makes a complete revolution in 1 second, what is its linear speed and what's its angular speed? The notation wise is like a little cursive V, and then this is the Greek letter omega. Looks like a W. Well, what's the linear speed? Linear speed is the distance of travel. If it makes one revolution, okay, one revolution, how far will it have traveled? Josh? The circumference. That's it. The circumference. So it makes one revolution. So for the linear speed, it will be the circumference, which is 2 pi times, in this case, 10. And so we get 20 pi. 62.8. And in this case, what's it going to be? Inches per second. The angular speed. Well, angular speed, just like everything else, depends on whether we're talking radians or degrees. Angular speed can be either one. So we're going to do both for this case. If it makes one revolution, okay, now it's a little bit easier to just think of, like without it rolling, like right here, it makes one revolution. Well, how many degrees does it travel? Travels 360 degrees. That would be its angular speed. So it would be 360 degrees per second, or 2 pi radians per second. Okay? And this is just kind of important to remember. Every time a wheel or a pulley, that's a common used object in this unit, makes one revolution, it will travel the length of its circumference, okay, linearly. Okay, so that would be its circumference. Which corresponds to the linear velocity. And it will rotate 360 degrees or 2 pi radians, which will be the angular velocity. Okay, so you get two things going on. You got a linear velocity, you got an angular velocity, okay, for that. All right, so let's say a 24-inch diameter, which means it will have a 12-inch radius. Bicycle tire is rotating at a rate of 80 revolutions per minute. All right, we're going to calculate the linear speed, and we're going to calculate the angular speed. Okay, linear speed and the angular speed. Every time it makes a rotation, it travels the length of its circumference. Every time it makes a rotation, it goes 360 degrees or 2 pi radians. So for the linear speed, since it makes 80 rotations, take 80 times 2 pi times 12, here's a tenth is fine. Maggie Purdy, what'd you get?
6,031.9.
6,031.9, and that would be inches per minute. All right, we agree? All right. The angular speed is gonna be 80 times 360 for degrees. 80 times 360, 28,800. So 28,800 degrees per minute. Okay. And now, same thing for radians, do 80 times 2 pi. And typically with radians, we're going to just keep it in terms of pi. So 160 pi radians per minute. Remember, 360 degrees is equivalent to 2 pi in terms of radian. All right, so there's your linear speed, there's your angular speed. Okay. A wheel with a 16-inch diameter is turning at the rate of 51 revolutions per minute to the nearest inch per minute. What's the linear speed of a point on the rim? All right, go ahead and calculate that. Nearest tenth would be 5. Make sure that you change the make sure the radius is 8. And velocity should be 51 times 2 pi times 8. Cooper, what'd you get?
I got 2,564.
Point anything?
It was 0.54, but it was to the nearest inch.
Oh, yeah, you're right. It's already on there. Inch per minute. We agree? Okay, so just multiply by 51. All right, let me, debating something here. All right, flip it over on the back. I'm gonna do this in a different order. Okay, this is similar to what we had. So just flip it over the back and then we'll go back to the other side. I'm gonna change this around a little bit. Okay, because this is similar to what we just had. All right, bicycle wheels are 26 inches in diameter. The bicycle wheels are making 3 revolutions per second. How fast is the bike traveling in inches per second? And then what would the answer be in miles per hour? Okay. So what we want to do is figure that out in inches per second and say, all right, what is that? Gets a little bit of reference point, change that to miles per hour. And so we have our radius will be 13. And so the velocity will be 3 revolutions per second times 2 pi times 13. Now, I think if we round it to the nearest tenth, it's just 0.0, isn't it? So if I just go 245, I think we'll be good. So go 245. Let's go, that would be inches per second. All right, you convert it to miles per hour. I'll give you one clue. 5,280 feet equal what? 1 mile. All right, see what you come up with. Round it to the nearest tenth when you are done. got it? All right, most everybody seems to be on the right track for the most part, except for Ryan. But we won't call any names out in terms of that. Jacob, what'd you get?
13.9 miles per hour.
13.9. Okay, miles per hour. Now, what's that process in chemistry you guys use where you do all the units? What's that?
Conversion factor?
Conversion factor, yeah, okay. So you guys are really good at that. I just kind of do brute force or just kind of figure it out a little bit at a time. So if it travels 245 inches per second, I don't care how you get it as long as you get the right answer. I would convert that to how many inches in an hour. So you would multiply so how many inches in a minute? Well, you got to multiply that times 60. That'll give you the number of inches in a minute, right? And then you take that and multiply it by another 60 to figure out how many inches is an hour. So that would give me 245 times 60 times 60, 882,000 inches in an hour. Well, now I need to convert that to miles. So I'd go figure out how many feet first. So if that's how many inches, to take that 882,000 divided by 12, and that gives me 73,500 feet per hour. And then take that divided by what? 5,280. And then we get 13.9 with the final answer. So we got 73,500 divided by 5,280 gives me 13.9 miles per hour. Okay, for that. All right, flip back. All right, dealing just with these formulas again. If an object travels around a circle radius r through an angle of theta radians. All right, we are talking in radians, not degrees. Theta has to be in radians. Okay, we got an arc length of s and a time t. Well, velocity is just basically distance divided by time. So if you take the arc length divided by time, that'll give you the linear speed. If it's traveling more, like it's traveling for 10 seconds or 15 or whatever. The angular speed will just be the angle divided by time. All right, well, let's take a look at velocity here. So we know velocity, hold on here. Velocity equals S over T. And I know S equals R theta. So I can take R theta and substitute it in for S. So that becomes R theta divided by T. Well, what does omega equal? Omega equals theta divided by time. So I can replace theta divided by time with omega. So what that boils down to is the velocity, this is going to be at the bottom there, is going to be the R times omega. Okay, that will be another fact. Only if the angle is in what? Radians. Only if the angle is in radians. So theta has to be in radians. Now this formula can make some problems that look difficult really easy. But you can also solve those problems other ways without using that formula. It's just a very convenient formula if you recognize when to use it. To be honest though, I'd say only about 30% of the time do people recognize that they can use it. So you have to have other ways to go about it. All right, so velocity equals R times omega. All right, we're going to do one problem out of your book here together. So page 526, take a look at number 99.
It's gonna be right there, it's right in the middle of
Oh.
That's one of the questions.
Could be.
See? I'm gonna go with these.
Or we're gonna do it the easy way and the hard way. Alright, there's two parts to it. Part A, we're gonna do the hard way, and part B, we're gonna do the easy way. For this. You got two pulleys connected by a belt. The belt is traveling what, 600 inches per minute? The bigger pulley has a radius of 5, the smaller pulley has a radius of 2. We want to find the angular speed in radians. Okay, because sometimes it doesn't always stay. We want it in radians. What is the angular speed in radians for the larger pulley? All right, I want to do it the hard way first time because there's going to be times we actually need to do this. I want you to tell me how many revolutions the bigger pulley makes in 1 minute. So you can figure that out. How many times does it go around? How do you do that? Okay, so think about that. How many revolutions does a bigger pulley make in 1 minute? All right, how can I figure that out? There's no fancy formula, you just kind of got to understand it. How do you figure that out? Anybody ideas? Cole, you got any ideas to look at?
I just found the circumference of the pulley and then took 600 divided by that answer.
Okay, that's exactly right. The linear speed is 600. So it doesn't move, but you got to think, what would happen if it moved? It would be traveling 600 inches. Okay, so you got to think that even though, so that means a point on the rim is traveling 600 inches. If you need to think about it linearly, that's fine. But you have a wheel here, and so every time it makes a rotation, it travels the circumference. So if you want to know the number of revolutions it makes, you're going to take 600, so the revolutions will equal 600 divided by 2 pi r. So that's 600 divided by 10 pi, okay? Which is what, 60 over pi? Now, it doesn't come out to a nice number, but if you do 60 divided by pi, is it 19 point something?
Yeah.
19.3? I'm just guessing. 19.1. All right, so approximately 19.1. So approximately. All right, but keep that in there. So approximately 19.1. Well, if we want to find omega, the angular speed is just how many radians it travels. Well, every time it makes a revolution, it travels how many radians? 2 pi, right? So what do? We take the number of revolutions, which is 60 divided by pi, and we multiply that times 2 pi. That's your answer. Okay, so the angular speed is the number of revolutions times 2 pi, which is going to be 120 radians Are we minute or second? I think we're minute, right? Minute, radius per minute. Alright, that's the hard way. But sometimes that's gonna be the easy way depending on how you look at it. Let's do the easy way for the second one. What's the easy way? Easy way is the formula we just went over. Velocity equals r times omega. What's the velocity? 600. 600 equals the radius, which is 2 for the smaller one, times the angular speed. So if I divide by 2, I get 300. If you use that formula, it has to be in radians. So it's 300 radians per minute. Now, as I said earlier, a lot of times you don't remember the formula or you don't recognize when to use it. There's always another way to do it. It's based upon the number of revolutions, so it just depends upon the scenario, okay? All right, so I at least want to do that one together. All right, I want to give you some time here. Skip 5 and 6. We didn't really cover them. Not that you can't do them, or don't have the intelligence to do them. You just didn't really cover them. That's the area and
$15 questions.
So when we did the easy one, why did we end up with a different angle than we did with the first one?
Because the small pulley has to travel more.
Oh, wait, I didn't realize that was the small one. Got it. I wanted to do the same one. Sorry. There we go. Thank you.